Alright, plotting log graphs. How do we do it? First things first is let's take a look. We can't have a log of a negative, right? Why? Because if this is negative, then the base also has to be negative. Like, 10 to the power of what is minus 1? Exactly, that question just doesn't make any sense. Alright? So, I'm just going to tell you this one, just to warm up. The log graph will look something like this one. Yeah? Y here is equal to ln x. You can see it slowly increases, but it can't actually equal 0. Okay, and you can't have x as 0 or lower. Just doesn't make any sense. Now, if this is y equals ln x, how are we going to write down 2 ln x? Well, if you remember from the functions, we know that this is the same as 2f of x, which is a stretch in the y-axis. So it's going to look something like that one. Yeah, y is equal to 2 ln x. Now, let's take a look at these ones. Y equals ln of x plus 2. All we're going to do is we're going to shift it to the negative, which is to the left, by 2 points. Which graph does that? Exactly, it's graph number 3, isn't it? Y is equal to ln of x plus 2, okay? Which means by process of elimination, this one has to be, right, y equals negative 2 ln x. But if you think about it, it makes sense. Why? Because this negative is a reflection on the x-axis. And so now you understand how the log graph works. You can understand how any of these work. Is this video helpful? Well, make sure you subscribe so you never miss a video like it from me. Now let's look at working out the inverse function. How are we going to do that? Well, if f of x is equal to e to the x, I'm going to do two sides, right? If f of x is equal to e to the x plus 1, all we need to do is let's just let f of x equal y, okay? Let's make y the subject. E to the x is equal to y minus 1. And now we need to do the reverse because it's the inverse function. So we're doing ln of x, e to the x, which is equal to y minus 1, ln of y minus 1. And because it's ln of e to the x, the ln and the e will cancel out. So this is the same as y minus 1. Okay? Now, let's take a look at this example. G of x is equal to ln of 8x plus 56. So how are we going to make this x the subject if this is equal to y? Well, if this is ln, right, or log, the opposite of a log is an exponential. So let's do e to the y is equal to e to the ln x plus 8x plus 56. And as we know, because we are doing an exponential for ln with the same base, the ln and the exponential will cancel out. Now let's minus 56. So 8x is equal to e to the y plus 56. And so therefore x is equal to e to the y plus 56 over 8, which is equal to 7. So g of x is equal to an eighth. an eighth of e to the x plus 7. And so it's the same thing as an inverse function, only this time we're just using logs and exponentials. I hope that makes sense, but if it doesn't, join my Discord server to send me whatever questions you want. Now, let's take a look at a little word problem. Write down the corresponding letter to each equation. We have L, N, and M. Which one is which? Well, we know that e to the x looks like what? This is y, this is x, and this is naught. This is y equals e to the x. Minus x, right? What's that the same? That is a reflection on the y-axis. Which one is reflected on the y-axis? It's L, isn't it? Why is it L? Because e to the x is pointing that way, but here it's pointing that way, as you can see. Now, what's next? Y equals 2e to the 2x. Well, which one of these passes through origin at 1, do you think? Or no, at 2, do you think? It's going to be n, isn't it? Why? Because this one is the most stretched. And this one is 2. Why? Because e to the 0 is equal to 1. And of course, this one has to be m. Why? Because it's shifted plus 3 in the x direction. Okay, so how are we going to work out what a is here? Well, this is the point at which L and M are equal. So, e to the 3 minus x is equal to, what is that, m? So that's e to the x minus 3. So therefore, 3 minus x is equal to x minus 3. And so x is equal to, 2x is equal to 3. And x is equal to 6. X is equal to 3. That's point 1. Where do they intersect? Well, they intersect at y is equal to 1. How do I know this? Well, for each of them, right, e to the 3 minus 3 is equal to e to the 0, which is equal to 1. So that's why I get 3, 1. Now, how do we work out what b is to 2 decimal places? This is where it's L and N. So again, let's equate them. I am running very low on space. Apologies, guys. So for this one, we can't use the same logic because we have a 2e to the x. So that's where we use our logarithms. 2e to the 2x is equal to e to the 3 minus x. So ln of 2e to the 2x is equal to ln of 3 minus x. And so therefore ln 2 plus ln e to the 2x is equal to ln is equal to 3 minus x. Why do I say it's equal to 3 minus x? Because the ln and the e will cancel out. Same with this example, the ln and the e will cancel out. So now we can solve a simple equation. Ln 2 plus 2x is equal to 3 minus x. Which means that, with some simple rearranging, x is equal to 3 minus ln 2, all divided by 3. And if we plug that into our calculators, we should get the correct answer of 0.77. Okay? Alright. Now, how will we find the inverse of this function? The inverse of this function, I'll write this down on the bottom row. Really sorry about the lack of space. Y is equal to e to the x minus 3. So therefore, what can we do? We have to log them both. Ln of y is equal to ln of x minus 3. E to the x minus 3. Cancel out that. And so therefore, x is equal to ln y plus 3. And those are your final answers. Thank you guys for watching. If you guys want to pass your exams, drop me an email and we can organize a meeting and a quote so that I can tutor you. Keep on learning as you have no idea what you're capable of doing.